So to continue, we have space hours of supply, which is obtained using this equation, which has efficiency factor, small letter f, multiplied to the summation of t sub I, which is the total length of time in hours when the I space can be legally parked on during the specific period when I is equal to 1 to n is the number of parking spaces available. You have to take note that our f, which is our efficiency factor, is used to correct for time loss in each turnover. It is actually determined on the basis of the best performance a parking facility is expected to produce. And we have to take note that our efficiency factors should be determined for different types of parking facilities. For example, our surface lots, you have to identify the efficiency factors, our curb parking, and garages. So our efficiency factors for curb parking during highest demand may vary actually from 78% to 96%. For surface lots and garages, it may vary from 75% to 92%. And the average values of F are 90% for curb parking and 80% for garages and 85% for surface lot. Now we have a problem. The owner of a parking garage located in a CBD has observed that 20% of those wishing to park are turned back every day during the open hours at 8 a.m. to 6 p.m. because of lack of parking spaces. An analysis of data collected at the garage indicates that 60% of those who park are commuters, with an average parking duration of 9 hours, and the remaining are shoppers with an average parking duration of 2 hours. 20% of those who cannot park are commuters, and the rest are shoppers. And a total of 200 vehicles currently parked daily in a garage. Determine the number of additional spaces required to meet the excess demand. Assume parking efficiency is 0.90. So for this one, so to calculate our space, our demand, so we have here the equation. Of course, this is the equation for our space, our demand, which is summation of n sub I times t sub I from I equal to 1 to n. And to have the computation to commuters that is being served, so of course, from our problem, there are 200 vehicles and 60% are commuters, and it took them 9 hours for their parking duration. So the commuters that is being served, we have 0.6 times 200 times 9, so it gives us 1080 space hours. So 0.6 is the 60%, which refers to the commuters. 200 is the number of vehicles, total number of vehicles that park daily in the garage, and 9 for it is the number of hours that commuters, that is the duration of the parking, duration of the commuters as they park on the garage. Then for shoppers now being served, so from the 200 total number of vehicles, 40% are shoppers, and it took them 2 hours to park on the garage. So we have now equivalent value of 160 space hour. So which means that if we're going to have the total number of vehicles turned away, so that will be equivalent to, since if 20% of those who cannot park are commuters and the rest are shoppers, and a total of 200 currently are parking, are currently parked daily in the garage. So which means that if there will be, what will be the total number of vehicles turned away? So that will total number all over 0.8, since we have this, we have here 20% for those who wish to park are turned back every day during the open hours. So those who turned away are 80%. So that will be 200 all over 0.8 minus 200. So that will give us 50. So this is the total number of vehicles that turned away. So commuters not being served. Of course, for the commuters not being served, so that will be 20% of those who cannot park are commuters. So that will be 0.20 times the total number of the vehicles that turn away. So times 50 times 9, that is the number of hours, to park on the garage by the commuter. So that gives us 90 space hour. For the shoppers not being served, of course, if there will be 20 80% for the commuters not being served who cannot park. So 80% of that are shoppers. So that will be 0.8 times the total number of vehicles that turned away times 2. This is the duration of parking for the shoppers. So that will be equivalent to 80 space hour. So which means that the total space hours of demand, you simply have to add our 1080 plus our 160 and plus our 90 plus 80. So this is the total space hours of demand. So it gives us 1,410. And the total space hours served, that will be equivalent to, that is the total space hours served. That means that is the number of hours, or that is the total space wherein the commuters and the shoppers were able to use the parking space or the garage. So that will be 1,080 plus 160. So it gives us 1,240. So which means the number of space hours required will be, so that will be the demand minus the space hours served. So the demand minus space hours demand and minus space hours served. So 1,410 minus 1,240, it gives us 170. And definitely, we can have now the number of parking spaces. So the number of parking spaces, you have the formula. And it will give, actually, this is the number of parking spaces required is equivalent to the number, this one, 170, because this is the number of spaces that is required, or that is now equivalent to the number of parking spaces required, so that everyone will be served and can use the parking area or the parking garage. So equal to 170 space hour. So the if we're going to have now to determine now the number of additional spaces. So to determine the number of additional spaces, so we simply have to multiply. We have here our parking efficiency, which is 0.90 times number of hour from 8 a.m. to 6 p.m. It is equivalent to 10 hours. So that will be times 10 times n to determine the number of spaces equal to the number of parking spaces. So if we're going to identify now our n, the number of additional space, so that is 18.89. So which means that we need 19 additional spaces so that everyone can be served.